I was with this professor, Michael Porter, today at our management track. He and I gave a 2-hour session, and you may or may not know him, but he's one of the most famous professors on earth because he's the most famous professor at Harvard Business School, and that's one of the most famous schools on earth. So he's a very famous guy, and his specialty is strategy. And he always says there's 2 parts to strategy. Number 1 is determining what are you going to do that is unique and creates value. And the second thing is then doing it very well, okay? But you must have a unique strategy, and then you must execute it well. Common sense, I guess. But so I look and say, and he says, and it's not good to have the same strategy as your competitors, because then it's not a unique strategy. Then you're doing the exact same thing. The only way to win is everybody to cut prices, and then there's no profit, and blah, blah, blah. So I think 5 years ago, PTC and Siemens and Dassault looked very similar. But I think in the last 5 years, we've gone down very different paths. And I like our path a lot. Dassault has said, what other problems could we solve with 3D? And they're off with Geovia and Biovia and RTT. And, they just want to do whatever they can do with 3D. The problem is those are all independent strategies. It doesn't help Geovia one little bit to be part of Dassault. There's no technology sharing, no customer sharing, no sales rep sharing. It's just like a little business that's in a holding company called Dassault, but no benefit. They can't cross-sell. We can't sell mining geology software to an automotive company or CATIA modeling software to a mining geology company. It doesn't make sense, okay? Same thing with this Biovia thing that they recently added. But that's their strategy. Good for them. Hope it works. I'd be concerned if I was the CEO of that company. I'd be very concerned. Say what I think Siemens has done is gone deep in the link from engineering to manufacturing. I think in some industries, that's interesting. I think in other industries, it makes no sense at all. Because the general trend of all manufacturing for the last 20 years has been to separate engineering from manufacturing. Siemens talks about design the factory for the product, design the product for the factory. I could name thousands of customers who'd say, that's ridiculous. I'm trying to do design anywhere, build anywhere. I'm trying to say any engineer should be able to build any product for any factory, and any factory should be able to manufacture any product. Okay? So now, I think in some industries like automotive OEMs, it's more interesting because they do have so much automation that maybe they think that way. But even there, I don't know. And then the other thing is, parts of the product don't get made in factories. The soft part doesn't get made in factories. It's not even a factory to discuss. So I think that our strategy is more in line with the way the world's going. The world doesn't want to weld engineering and manufacturing together. They want to think about products becoming smart and connected and service models. And I want to be able to outsource or insource. I want to be able to build it in Japan or India or China or wherever. And the factories are different. So the question then is, how can I take a design and quickly transform it for this factory or transform it differently for that factory? We're pretty good at that. But it's just a strategy. I would not trade strategies, not for, millions of dollars. I wouldn't trade strategies. Because I think our strategy is better. And I like the fact that it's different now. Because I think we're doing what we want to do, and they're not doing that, right? We're not chasing them, and they've elected not to chase us, and I don't know why, but that's good. We'll see if it's good for Dassault. We'll see if it's good for... Dassault actually, has had 15 years of great performance, but not the last 2 years. Their revenue slowing down. They're struggling. We have a small strategy group. In fact, the guy who was sitting next to me, Barry Cohen, is the head of strategy. But they don't make all the decisions. They drive a process of engaging the company in debates about strategy. So there's what's called a strategy council, which would involve representatives from product groups and technology groups and sales and services and me and people like that. And we have regular meetings, and we might do some research. Maybe there'll be a question asked that needs some research. We'll do some research and then review it. But kind of a constant agenda of strategy discussions that key leaders from different parts of the company participate in. Because I think the key thing for strategy is it never works when it's Moses coming down from the mountain with the tablets and saying, here you go, here's the strategy, because everybody says, you're crazy. You don't know what you're talking about, right? So our process is very inclusive. Some dedicated people to make sure that it gets done, because it takes energy, but then very inclusive process of trying to make sure we have alignment between the different stakeholders and, viewpoints of the corporation. And therefore, like by the time we acquired ThingWorx, all the key leaders in the company wanted to be in the Internet of Things business, because we had all been through all the logical sort of strategy debates as to whether or not that made sense, and concluded together that it made a lot of sense. The key thing, though, is to try to do it in a way that has a lot of data and a lot of debate and involvement, right? Because everybody has a view, right? A view and a bias, and they'll argue loud and so forth. But when you present data, then it becomes more clear. I do have a philosophy here, as it relates to our portfolio of software products and software products in general. And that is integrate apples with oranges and consolidate apples with apples. Meaning, if you have two systems that really do the same thing, or mostly do the same thing, you should try to consolidate them into one system to reduce complexity. Like, for example, we used to have Pro Intralink and Windchill, and the truth is they kind of did the same thing, and when you integrate them together, it was just very problematic integration. And then at one point we said, okay, let's just be honest. We need to have one product, not two here. So we consolidated them. But then I said you should integrate apples with oranges. So if you have a PLM system and an ERP system, and they do pretty different things, then the best thing is to integrate them together. And then I think the right way to do that is service-oriented architecture. And this is where ThingWorx gets interesting. ThingWorx, in order to solve the problem of connectivity of things, they said, well, there will be many different things which will have services, and there will be other systems like PLM and ERP that will have services. And so ThingWorx must be able to combine services from any service provider, thing, or system into applications. So it's a great integration tool. Even if you didn't have any connected things, if you're just trying to integrate Windchill and SAP, ThingWorx is actually kind of an interesting tool. So I think that we have this strategy around service-oriented architecture, and we have a strategy around consolidation. So we're always looking for, do we have two products that should be one product? And then how do we integrate different products together that should remain different products? Now, sometimes the answer is not clear if it's an apple or an orange, and we debate that for a long time. Should PLM be architecture for software source code management? I don't know. You can argue that for a long time, and smart people on both sides of that argument. Some people say it's a different problem. You should have a different approach to solve it. Other people say it's just product content. Why wouldn't you put it all in one system? So let me say, we do have these questions all the time. Should we try to have one single system that does everything, or modules that work together and can be moved independently? We have always resisted the temptation to weld Windchill and Creo together so that they have to be upgraded at the same time. Maybe other vendors will do that. We've always said no, because customers want them to be separate. They want to be able to do a tool upgrade without doing an enterprise system upgrade. And they want to be able to do an enterprise system upgrade without having to simultaneously do a Creo tool upgrade. So that's an example of a modular architecture. Things work together very well, but the separation is clean. Creo and Windchill are different animals. They're apples and oranges. It gets more complicated when you have two tools that aren't so clean and separate, because then the integration gets complex. So I think that there's this right balance between, on one hand, you don't want to have just one platform like ERP because it becomes unmanageable, so big and complex. On the other hand, you don't want to have 100 different systems you're trying to integrate together. So consolidate down to major platforms and then integrate the major platforms together. PTC has focused on three key problems, which is value, being shared between hardware and software, between the product and the cloud, and between the product and the service. That's what we focused on. To a certain degree, Dassault and Siemens have focused on the link between engineering and manufacturing more than we have. Now, we have this MPM-like product that's really good, but we don't have the MES piece on the back of it. That's why we partnered with GE, because we sort of feel like if we take our strengths and their strengths, then we have a pretty good answer for engineering to manufacturing integration as well, and then unique answer for software, cloud, and service, right? So we like that strategy. The truth is we can't do everything. It's just hard, and it's hard to find enough smart people in the company to solve every problem from ThingWorx to MES to ALM to systems engineering to SLM and so forth. So we think in some cases a partner is good, and we elected to go with a partner strategy there and then selected a big important partner. By the way, their headquarters is here in Boston too, so they're convenient and close by. GE sells big products, jet engines, power generation things, whatever, and then they sell service contracts. So they have $200 billion worth of service contracts to perform over time. And they're saying if we could perform, and they're fixed price contracts, so GE already knows what GE will be paid. They're like our maintenance contracts, okay? So GE is saying if we could perform those service contracts even 1% more efficiently, 1% of $200 billion is actually $2 billion of profit, right? By being 1% better, we could generate $2 billion worth of profit. So by connecting things to the industrial internet or the Internet of Things, could we be 1% more efficient? Absolutely. We could be more than 1% more efficient. That's why they're, Jeff Imholt, who's the CEO of GE, this is his personal strategy. I think the concepts are very similar. I think that in Germany, they're only thinking about the factory. They're thinking about a smart factory, not as much about whether or not the factory produces smart products. But I will tell you that Siemens automation guys told the ThingWorx guys when we were at the HMI conference together, because their booth was right next to ours, they said, why didn't you call us before you sold the company to PTC? Because we would have been very interested. Because ThingWorx can also be used for Industry 4.0. And in fact, we'll add it to this GE relationship. We already have a common customer using ThingWorx and GE MES for Industry 4.0 type automation. So I think, it's similar but different. The U.S. view is much broader. The German view is focused on factory automation. Yeah, I mean, the main thing we were looking at in our research project is smart connected products, let's say, is it disruptive to the status quo? Or is it just a tweak? And we concluded that it was very disruptive. By that, it means it changes a company's value chain and it changes the way industries work. I'll just give you an example. When automotive companies start using Android operating system, that's interesting because automotive companies are used to pushing around suppliers, but Google is worth more than any automotive company. Automotive companies can't tell Google what to do. They can't. If you don't want to use Android, don't. I don't care. Nobody will buy your cars. That's your problem. So that's an example of one dimension of the value chain or of the industry structure, which is how much power do your suppliers have. So automotive companies, for example, need new suppliers. Some of these suppliers are very powerful. Some of these suppliers will disrupt the relationship that automotive companies have with their customers. Like if you drive a BMW, you always talk to BMW about problems. But if you drive a BMW that runs Android, you might start talking to Google about how to make your BMW work better. BMW doesn't like that. But what do? Compete with Google and Android? It's a tough decision, right? So we have many findings like that, and that's just one made-up example. Many findings that say this is a big, impactful thing. And again, one of the biggest concerns amongst the executives we talked about is security. It comes up in every conversation. But I think most of them agree we must overcome this problem, but we must be careful. It's like credit card processing, this U.S. company, Target, got into a lot of trouble because their credit card database was hacked. Okay, so it's sort of like, if we're going to do this, we have to be careful that we don't ruin the reputation of our company by leaving some door open. So we should do it, but we must be careful. But the key takeaway is this is important. And Michael and I have had numerous sessions with CEOs, people who would never show up to talk about CAD or PLM. They show up to talk about Internet of Things and smart connected products because it could hurt their business, to not be aware of this and not do the right things. ThingWorx is a big data system, and it sits on top of a Hadoop or a Neo4j database, big data database. It doesn't run on Oracle, it runs on a big data database because it's collecting data readings from many sensors on many things. And these sensors don't just have a value, they have a value per second or per time slice. So you're dealing with streams of data, many, many streams of data coming in at once, and you want to keep that data so you can see performance over time, okay? So that's big data. Now that brings us to the question, what about big data analytics? And what I would say is there's a couple parts to that strategy. First of all, sometimes the analytics are not big data, they're what I call little data. For example, if you have an automobile and there is a temperature sensor on your engine, I know if your engine gets too hot, there's a problem. I don't need big data to tell me there's a problem because your engine's too hot. That's why I put that sensor there, was to watch for that problem. So that's what I call little data. If temperature is greater than this limit, then alert somebody. But there are other situations where you have this data, and if you analyze it, it will tell you things you didn't expect to see. Think of an industrial pump like in an oil refinery or a process factory or something like that. You pump in large quantities of stuff. If you just had 3 sensors on that pump, one to measure the pressure coming in, one to measure the amps of electricity used, and one to measure the pressure going out. And every second you got a reading from those 3 sensors, and you collected that for a year or more on 100 or more pumps. So you have all this data. And now you say, now let me go get the service records and overlay that. Okay? When did pumps fail? And so forth. And you'd look and say, if I overlay failures across the large body of pumps, do I see any patterns that developed in advance of a failure? For example, if the amps are going up and the pressure differential is coming down, the pump's failing, right? And maybe you'd see that pattern. And then you'd start to say, that pattern actually takes 3 weeks to develop if a bearing's going out. And so now every time I see that pattern starting to develop, I know in the next 3 weeks that pump will fail. Yeah. Okay? That's big data analytics to me. I think security is one of the biggest problems with the Internet of Things. I mean, there are a list of reasons to connect your products to the Internet and a list of reasons not to. And the top thing on the list of reasons not to is security. So it's the biggest concern. I think, though, in most cases, it's a addressable concern. If you connect your computers to the Internet, bad things can happen to your computers. But we all have our computers connected to the Internet. And we have our factories connected to the Internet, and we have our homes connected to the Internet. I mean, everything does get connected. So I think it's a problem. We must address the problem, solve the problem, but I don't think it will stop things from getting connected to the Internet. If you can hack into computers, you can shut down our electrical grid. You can shut down our subways. You can shut down our cities. You can shut down our airports because they're all controlled by computers. And most of those systems are connected in some way to the Internet. So the Stuxnet story is real, but I'm saying that already there are many things that are computer controlled, therefore connected to the Internet. But we put up firewalls and we use different security strategies and virus protection and so on and so forth to try to contain the risk, but still we do it. All banking is done on the Internet, right? You can steal all the money if you can figure out how to hack into the banks. But they have a lot of protection. It's not easy to hack into the banks. Anyway, I think it's a huge concern. I don't agree that it will block progress. I think it's a challenge. Everybody must address the challenge. But everybody already knows this challenge in various forms, and we address it every day when we connect our ERP systems and our banks and everything else, our hospitals, to the internet. So I think we must have partnerships, to give our customers options to address this problem. Because if you ask our customers, and in our research we've seen this, the number one thing they're concerned about is security. Everybody knows the story of Dick Cheney and his pacemaker. Everybody knows that story. But everybody also knows that we have, 2 billion computers connected to that same internet, and that many of those computers control things that, are a problem if they're hacked too.